All right, in statistics today, we're looking at the coefficient of variation. Coefficient of variation. This is what it is right here. The coefficient of variation, or just CV, is going to be your sigma divided by your mu, which is your standard deviation divided by your mean. And you times that by 100%, and that's your coefficient of variation. That's if you're doing a population. Now, if you're just doing a sample, which is most likely what you're going to do, your coefficient of variation is going to be your S divided by your X bar, which is your standard deviation divided by your mean times 100. Okay? So here's a problem here. We're going to go through it. I've already worked it all out, but I'll talk to you about it and then I'll do another one. But it tells about the coefficient of variation. You can use a coefficient of variation to compare data with different units. And that's what's good about this. You can compare different things amongst themselves. So like in this right here, we've got a group of people, we've got their heights and we got their weights. Okay, we can compare the height versus the weight with the coefficient of variation. That allows us to compare these two totally different things. Heights and weights are different. All right, so what I do is, let's get my heights, and I put the numbers in order right here. So I did height right here. So there's all my numbers in order, and I add them up, which is 852, and I divide by 12 because there's 12 of them, and there you go. There's my X bar. That's my mean. Okay. Well, then I take the mean and I subtract it from each one. So 65 minus 71, square it, I get this. 66 minus 71, square it, get that. And I do that for every one of these, and I wrote them all down. Okay, and then I sum them up, which is 170. Okay, now, this is a sample. Okay, set it up in the problem up here. This is a sample. Okay, so that means I divide by 11 on this number. So I do 170 divided by 11. There's 12 of these heights, but I take one off and divide by 11, which gives me 15.45 repeating. That's my variance. And I do the square root of that, and right here's my S. Okay, this is my standard deviation. So now once I have these two things, I can just come up here, I do my standard deviation, divide by my mean, times 100, and I get this right here, 5.53, which it says round to the nearest tenth, so I put 5.5. Okay. Now, do the same thing with the weights. So this is a little time consuming doing all these numbers. It's not really difficult, just takes a little bit of time. Put my weights in order. I add them all up, which is my sum right here, 2372, and I divide by 12 because there's 12 of them. And I get 197.66. That's my mean. All right, well, I just went ahead and rounded it to 198 to make my computations up here a little easier. Okay, so I just round it to 198. And now do 174 minus 198, square it. 183 minus 198, square it. And I do that for all these values, and I get all these numbers here. Okay, all right, when I sum these up, I get 3368. And I didn't mention this, but I did this twice, and you can see where I messed up here. See, the first time I wrote the number down, and then I did it again, and I got a different number. So I did it a third time, and I got that same number. So you do need to do this a couple times, adding these up, because there's lots of mistakes you can make, lots of ways you can make a mistake. So once I get this sum, since there's 12 of these, I subtract one off and I divide by 11. And that gives me my variance right there. And I do the square root of that, and right here's my standard deviation, 17.498. Then once I have these two numbers right here, I can take them up here. I do my standard deviation divided by my mean times 100, and I get this right here. That's my coefficient of variation, 8.8. It just wants it rounded to the 10th. So there you go, 8.8 is what I get for that. Okay, so I put these two answers in. Now what can you conclude by this? Okay, well, if you notice on here, the weight number is higher than the height number. And so what that means for these people, that the weight is more variable than height. Weight varies more than height because it has bigger number when you do your standard deviation divided by the mean. So since this number here is bigger, that means weight is more variable than height. Height doesn't vary as much as weight does. Okay, and that's simply what it means. Okay, which I can understand that to a certain degree, because you can have people with the same height. Like you could have people that are 5'10", and you could have one person that's 5'10" that weighs 160, and you can have another person that's 5'10" that might weigh 200. So the weights vary more than what the height does. Okay, so that makes sense to me. So maybe it makes sense to you. Okay, now there's a second problem. Okay, and you guys can do that one. Now this third problem, I'm going to do it full-fledged with you guys together. Okay, so we're doing another one. The ages in years. Let me get down here where you can see on the screen. The ages in years and weights in pounds of all wide receivers for a football team are listed. So this is all the wide receivers for a football team. Find the coefficient of variation for each of the two data sets, then compare the results. Okay, now, first of all, what I'm getting on this now, it says the ages and weights of all wide receivers. So we're talking about a whole population here. So this is a population. All right, so we have to keep that in mind. So that means if I look back at this again, I'm going to be doing this. I'm going to be doing sigma divided by mu. I'm not going to do S divided by X bar because we're talking about a population. This is for a sample. This is for a population. Which the only difference in that is your standard deviation calculation. All right, so here's my numbers right there. I'm going to do my weight first. All right, so I'll just write these down. Okay, I've got let's see here, 184s first. Mark it out, and then I got 190. Mark it out, and then I got 201 twice. Then I've got, let's see here, 213. Then I got two 14s. Then I have 217. Okay, and there they are. Okay, so just put these in order. All right. Now, first thing we're going to do is we're going to have to add these up. Okay. So let's see here. I've got 184 plus 190 plus 201 times 2. Got two of those. Plus 213 plus 214 times 2 of those. Plus 217. And I got 1634. Okay. Now I'm just going to write that up here. Okay. That's what I got this first time. I'm going to do it again. You always want to add these twice because you can make mistakes adding on the calculator. So I got 184 plus 190 plus 201 times 2 plus 213 plus 214 times 2 plus 217. And I got 1634 again, so I think I'm good then. All right, so when I sum these up, I get 1634. Okay, well there's 1, 2, 3, 4, 5, 6, 7, 8 of them. I'm going to divide by 8. So divide that by 8, and I get 204.25. All right, I'm just going to knock off the 25 and just round it to 204. Okay, so this is my mu. That's my mean, okay? So I need that. That's my mean. Okay. All right, now I'm going to do 184. Well, minus my mean and square it. That's going to be 400. I just did that one in my head. I'm going to do 190 minus 204 and square it. Okay, that's going to be, I think, 196. But I'm going to punch them on the calculator, okay? So I'm going to do 190 minus 204 equals, square it equals, that's 196. Okay. Maybe I should move this over here. So this is 196. Okay, let's get this little, there we go. Now I think we're set. Now I'm going to do 201. So 201 minus 204 equals, square equals, that's 9. So this is 9, and I got it again. 213 minus 204 equals, square equals 81. All right, 214 minus 204 equals, square it, equals 100. And I got it again. Then I got 217 minus 204 equals, square equals. All right, so here's all these numbers. All right, so once I find those, I add them up. Okay, so I did this first time. I got 1,064. I'm going to write it up here, and I'm going to do it again. I paused the video and did this real quick. So I'm going to do 400 plus 196 plus 9 plus 9 plus 81 plus 100 times 2 plus 169. And I got 1,064 again, so I think I'm good. Okay, so that's my sum of this column. Okay, now this was a population, so I'm going to divide by 8. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to divide by 8. So I divide this by 8. I get 133. This is my standard deviation squared, which is my variance. And now I do the square root of that. So I do the square root of that answer. And there you go. My standard deviation is 11.532. Okay. All right. So now my CV is going to be my 11.532 divided by my 204 and times it by 100. Okay. Oh, sorry, I didn't have it on there. Okay, so again, once I find these two things, I do my standard deviation divided by my mean, times it by 100. All right, let's type that in and see what we get here. 11.532 divided by 204 times 100, and I get 5.65. I think, let's see, does it say round to 1 decimal place? Yes, it does, round 1 decimal place. So, so this can be 5.7. Okay. All right. Now we're going to do the ages. All right, the ages, the numbers are a little smaller. It might be a little easier. Not having all these hundreds and stuff. And you get a piece of paper here. All right, we'll just put this to the side here. Okay. So we'll put these in order. So let's see here. 22. 22 looks like this first one. 24. I got two 24s. I've got two 27s. I got two 28s. And then I got a 31. 2, 4, 6, 8. There's all of them. Okay. So I'm going to sum those up. All right, so I'll bring the calculator in. Okay. So I've got 22 plus 24 times 2 plus 27 times 2 plus 28 times 2 plus 31. I got 211. Just going to write it up here. Okay, 211. And we'll do it again. We always want to do it twice because could make a mistake. And 22 plus 24 times 2 plus 27 times 2 plus 28 times 2 plus 31. 211 again, so I think I'm good. 211, and I'm going to divide by 8 because there's 8 of them. So 211 divided by 8 is 26.375. Okay, now I tell you this, I should leave, since these numbers are smaller numbers than the 200s. See, we had the 200s and 100s, all this. Since these numbers are smaller, I should round that. I should punch that in every time. So that's going to make it really complicated, but as far as a bunch of decimals. So like right here, I'm going to do 22 minus 26.375, and I'm going to square it. I'm going to do 24 minus 26.375, and I'm going to square it. I'm going to do that for each one of these. Okay, so starting off here, I'll move this over, get it all on the screen so you see what I'm doing. 22 minus 26.375 equals square equals. All right, I get 19.14. And I can round it once I get to here. 19.14. Okay. That's 24 right there. Okay. So now 24 minus 26.375 equals square equals. So it's 5.64. Okay. And this one's the same thing. All right. Now, 27 minus 26.375 equals square equals 0.39. Okay, that's what this one is too. All right, I like it when you got pairs like that. 28 minus 26.375 equals square equals, that's 2.64. And I've got 2 of those. And now 31. 31 minus 26.375 equals square equals. And that's 21.39. Okay? All right, there we go. Now, I'm going to sum those up. Okay, so let's add these up. 19.14 plus 5.64 times 2 plus 0.39 times 2 plus 2.64 times 2 plus 21.39 equals 57.87. I'm going to write it up here. Okay. And I'm going to do it again. I always want to do it twice. 19.14 plus 5.64 times 2. Okay. Plus 0.39 times 2. Plus 2.64 times 2. Plus 21.39. 57.87 again. All right, so I'm good. 57.87. Okay. And like I said, now this is a population here, so there's 8. I'm going to divide by 8. Okay, so I'm going to divide this by 8. And I get 7.23375. Okay, this is my variance. So I'm going to do the square root. Oops. I'm going to do the square root of that answer, which is 2.68. All right. So there's my standard deviation. So there's my mean, there's my standard deviation. Now for the CV, okay, so my coefficient of variation is going to be 2.689 divided by 26.375 and then times it by 100. Okay, so let's type that in. 2.689 divided by 26.375 times 100. And I get 10.195. 10.195, which would be 10.2. Okay? So, for the first one, I got 5.7. For this one, I got 10.2. Okay? And what can you conclude? Well, it looks to me like there's more variation. Since this number is higher than that one, there's more variation in the ages. The weights don't vary as much as the ages do. So that tells me then, right here on the bottom, ages are more variable than weights. Okay, so this would be C right here. Ages are more variable than weights for all wide receivers on the team. Okay, because this number is higher than that one. The ages have more variation. Okay, so that's it. That's coefficient of variation. That's how you do that. If you have any questions, just give me a holler. All right, have a good rest of the day.